I don't know, is this part 7? If not, I'll correct it. It takes me 100 times longer to find what I'm looking for. Oh, I have resistors. Years ago, when I had excellent eyesight, I could pick out the resistors right out of here. All I do is I use my good old charts, because that's the only way I can remember the code. Orange, white, and brown is 390 ohms. I looked through all these, and I don't have 390 ohms. Nowhere near it. It would take me a week of Sundays to look through here. And these resistors here, I ordered from China a few years ago, probably 2 or 3 years ago at least. 1,000 resistors, the price wasn't bad, half watt. But they're 10%. They're supposed to be better than that, but they're not. And now I got to go through all the packages, and you can see that I did mark them, but it's overwhelming. You can see where I marked the resistance. I checked them because the color codes that China uses is not a standard color code on these, so you have to take a measurement. Some of these were marked, but most of them were not. So I'm trying to find a 390 ohm half watt resistor, which goes between pins 1 and 7 of the 1R5 tube. The one that I unhooked right here, reads 470 ohms. And this is it right here. Number 30, 390 ohms. So it goes effectively between pins 1 and 7. 1 is common negative on the filament, and 7 looks like the screen grid. So I'll take my word for it. I think that's where it goes. Anyways, so I've been working on this for about a half an hour trying to find resistors. This is what takes me so damn long. I don't have any luck with this 150 ohm that reads almost 200. So I'm not going to go and change the rectifier to a 1N4007 unless I can go to about a 250 ohm here. I don't have it. Simple as that. And like I said before, I won't be ordering parts right away. I don't know when I'm going to be able to get them. So I figured I'd go and change resistors as I need. Now over here, wrong end. Over here, as I mentioned, I replaced that 022, and I did replace a 3,300 ohm resistor. I did that last night. Which is located over here. 3,300 ohms. Now, Radio Rescue is the fellow I was referring to that worked on this particular model radio, and the radio he was working on, that resistor went up about double. This one went up about 1,000 ohms or 1,200 ohms higher. So I did replace that. But I'm not going to replace the selenium until I can get a power resistor, 5 watt, that I'm estimating to be about 225 to 250 ohms. I just don't have it right now, so I'm going to leave that alone. I also don't have the line cap, so I'm going to put a regular cap in there. The chances of this radio being used all that much is not going to be very much. So while we're on the schematic, there are 2 resistors right here near the battery pack. Both of these have gone up in value substantially. But as I was tracing out the circuit, they're only used for battery operation. So they're in the middle of the chassis under the cap, so I'm not going to bother changing it because we're not going to use this on battery. If you trace out the circuit, the switch is open here, okay? So the switch is in the AC/DC operation, which mentions right down here. Okay, it's an AC/DC operation. In other words, you're running it on, in this case, on the AC line. So you trace the, well, this would be the negative. Unfortunately, I say negative. It's not a negative. It's a neutral. We're not dealing with DC here. We're dealing with AC. Although years ago they used to have DC in the houses. So that switch is set for AC/DC operation. The levers are up. Okay. So if you trace back, I got a bad cold, so I'm sorry. I could hardly breathe last night. It felt like my windpipe was going to clog up. Very scary. I had a sore throat about 3 days ago on one side. It hurt like hell in the middle of the night. Then as the day went on, I cleared up. And I had one good day, but I felt like I needed to clear my throat, but I couldn't. And then the sore throat came back yesterday on both sides, but not as severe. And that's when I had a lot of trouble. And I had a hell of a time sleeping. My nose was totally blocked up. I had to take a spray to clear it out. And it felt like like my windpipe was partially blocked. It was very scary. I seem to be okay now. Anyways, you can see that that's out of circuit. Okay, those two resistors right there, they're out of circuit. We're spending a lot of time tracing this circuit out. So the switch over here is up, and it brings those resistors to common negative. See where the switch is? Up. Okay. So that will complete the circuit for this area here. And again, I can't read that. I have to look at it on the computer screen. To the 3S4 audio output tube. So I was scratching my head, figuring out, do I really need to replace these resistors? And from what I can see, these two resistors right here have gone up in value quite a bit. They're buried in an awkward place underneath where the capacitors are that I replaced. But they're not needed. They're only used for the battery. So if you follow the B battery's out of circuit. Okay. So you don't need to worry about that. You follow, that's the A battery, I'm sorry. I'm sorry, I can't see what I'm doing. This is the B battery. It ties to the center point of those two resistors where they join. It comes down here, and the B battery is out of circuit. And even if it was turned on, this here switch is the switch for when you plug the cord in to operate it on battery. That's that switch. This switch here is the little push button switch when you open the cover. So regardless of where that switch is, these resistors are out of circuit. So you're only concerned with the common negative going up here, going through this point and up here. So that's okay. You follow these resistors, as I said, and you follow the B battery, it's not in circuit. So check it further on the second resistor here, and you're connected to the A battery. A battery's out of circuit because it's not set up. It's set up for AC/DC operation. So that's clear. So you go down here and over here, and you're out of circuit. So I don't need to worry about that. Now, I wouldn't attempt to remove that switch and rewire it like Greg did with his radio. That is extremely confusing, and I know that if I tried doing that, this radio would never work. There's too many connections on that switch, so no point in worrying about it. We're not running it on batteries, so we don't care about that. So what I am in process, I keep using the term what we, I myself and I, me, myself, and I, checking the resistors. So we got another resistor here, 100,000. It appears to come off of common negative and goes to pin 4. I don't know. Yes, pin 4. I had to get the magnifier and go on the schematic with it. 100,000 ohms. So, all right. So that would be... No, that's a blue. First band is blue, gray, and brown. All right, so that's not it. But we're going to test that as we're going along. This is the 390. This is the 390. I can't find it in my box. I see a yellow band. That's buried way in there. I'm going to try to measure it, but I can tell you one thing. I'm not going to be able to get in there to do it. So this is the 390 ohm resistor right in front of you here. I just pushed it back onto the terminal. It's clipped off at one end. I had to take the tube out because essentially it goes across the filament, and you don't want these resistors to be high in value because they probably clamp the voltage a little bit so it doesn't get too high in the filament. So you don't want to have a resistor that's 470 ohms when it's supposed to be 390. So off camera, I'm going to try to get in there and test it. I'm not happy with this at all. I was looking back on my videos, and it looks like it sets down in here, but with the speaker out, I don't know yet. And this here cap got a coil on it. I think it's an 02 or an 05, one or the other. Don't remember now. And somebody told me it was a gimmick. I don't think so. There is a gimmick right here. Right where my thumb is. See that? A dead end coil? Okay. What we're referring to is this assembly here. This coil and this capacitor. All right. 02, I think. Hey, I can't read that. Goes to chassis. Okay. So they're in series. So that coil is a coil, not a gimmick. This is a gimmick. Okay. Two different things. So it is in a circuit. I'm going to have fun tonight trying to sleep. I take my cough medicine every 4 hours. That's all I can do. I don't think I'm going to change that cap. There's very little voltage across it from what I can see. So, because the newer caps would be smaller in diameter there's no way I'm going to try to wind that coil and put it in there. Not with my eyesight, I can't do it. We're going to leave that in there. This one here, however, is a cost of line cap, and if I don't have another 0.047, which is what this is, a 0.05, the cost of line, I'm going to just use a regular one. They've gotten away years ago with using regular caps in here. Use a 630 volt DC rated cap. Now here's what I've always understood and I've always said throughout the years. Your AC line voltage, peak to peak, on 120 volts is about 170 volts peak to peak. Okay. So, generally speaking, from what I was told by several guys in my, that I've talked to from the old school, if you got a DC rated cap that's rated for 630 volts in DC, which is all these new caps now that they sell, DC, it's at least rated half that much on AC. So that would be 330 volts. No, 315 volts. 630 DC, 315 AC. That's an approximation. So you put a regular cap in here, the chances of it blowing is probably zero. And if you leave this thing plugged in 24/7, which I don't recommend anybody to do, I've got several vintage radios on my computer desk, and none of them are plugged in. They do not get plugged in. Tell you the truth, they haven't been played since I put them in there after I restored them, because I got a computer that I got to literally unplug the power supplies from and everything else, and there's just too much RFI in the house, too much radio frequency interference. But none of the radios, including these, when they get done, will ever be left in and only plugged in when they're being used. Because they're turned off doesn't mean that these caps are not energized. And the way this is set up now on the schematic, when the switch is off, and that's the main power switch right there, when it's off, it is disconnected from the neutral line. Now, because of the way this radio is wired, I'm going to have a polarized cord on here, but I'm going to have to take the neutral and put it on this lower leg here, which is supposed to be the neutral, but it's switched. Not the way to do it. So, if you do that, when the radio is on, it's safe. When the radio is off, your chassis is hot. Although there is an isolation between the chassis ground and the B minus, which that's the B minus, and the chassis ground is this. So, I know I'm doing a lot of talking. This is more of an educational, what little knowledge I have, I like to share. I don't have much, I don't know a lot, and I'll tell you right now, I'll be honest with you. So, if your radio is switched off, and your hot side of the line is still activated and going through, you're still getting your hot wire coming through, your rectifiers, your dropping resistor, your tube filaments, and so forth. Although the circuit isn't complete to operate the radio because the neutral is switched off. However, you can still get a shock from that by way of the tube filaments because they're in series, and probably won't on the DC on the B+, but so normally I rewire the switch on an All-American 5 radio, not a battery set like this, because there's no way I can do it that I can think of, and I don't think anyone's ever done it, unless you do away with this whole complicated switch arrangement. And then you can make the major change and switch the hot side, which would be at this point here, before the line bypass cap. That's where you want to switch it. I never liked the way they did radios and always switched to neutral. Of course, years ago, you didn't have polarized plugs, so it depends on which way this was put into the wall, would determine whether or not your chassis would be hot. But there's no way I can make the change on this, as I said, and I am not going to take this out with all these wires, trace them out, and just wire this so it would be strictly AC. Taking the battery boxes out is all I'm going to do, and I've done that, of course. So here is where the line goes in, and the other one is connected to the common negative, which is the terminal right here for it, next to the output transformer. So I'm going to end this video now. I just want to let you know that I'm in the stages of testing resistors, and I got a week of Sundays to go through and try to find a 390 ohm resistor. So frustrating. All the parts I have, you know, it's overwhelming. All the resistors I have, and I don't have a 390 ohm resistor. Oh. So, before I started this video tonight, it's going to be another 4 to 6 gigabyte video file again. I'm going through to look for this. Now, according to the parts list, that 390 ohm resistor is a half watt. These are half watt. It just goes across, it's in effect goes across the filament, even though it don't show going from 1 to 7. I'm going to knock off for tonight. Oh, I got to hunt some resistors down. And that's always been the case with me. I don't have enough drawers to store resistors, so they have to be loose like this. My cabinet up here has what I think is the most common values. I thought of taking two 1,000 ohm in parallel, but that's 500 ohms, and I'm getting 470 now with the one that's in there. That's kind of stupid. You want to get it down to 390, and I just don't have anything I can put in there to get it to be 390. And I don't want to put two in series. There's not enough room. Not enough room for two resistors in series. Two resistors in parallel, well, they'd be twisted together and close. I could probably get that in there. All right. This ends this video. Thanks for watching. Have a good night, everybody.